Hello, my name is Maria Smith, and today I'm going to show you examples on how to solve functions. So we're going to start by using the calculator. We're going to go to y equals, and given any function, what you're going to do is what you see on the left side of the equal sign, you're going to put in y1, and what's on the right side, you're going to put in y2. The first function that we're going to do is the cube root of 6x plus 9 plus 8 equals 5. So I'm going to go to math, and I'm going to look for the cube root, which is option 4. That brings it there, and I'm going to type in 6x plus 9. Make sure I'm out of the radical. Notice that I moved out, that used the right arrow to move away from the radical. Then I'm going to do plus 8. And then I'm going to move to y2 and type in 5, because the function was cube root of 6x plus 9 plus 8 equals 5. What I'm going to do next is use the intersection function on your calculator to determine what the solution is to this equation. So I'm going to go second trace, and I'm going to use the option number 5 for intersect. So option 5. All right, notice that whatever I graphed last time, it kind of adjusted my window. So I need to reset it to the standard grid to see what I'm dealing with. So let's go to zoom 6. Okay, we have a better picture of what the graph looks like. This right here, the one in blue, is my cube root of 6x plus 9 plus 8. All right. This right here, the straight horizontal line, is my y equals 5. Notice they do intersect at a point right here. So what I'm going to do, I'm going to press second trace 5 for intersect, and it's going to ask me for the first curve. And look what is located as the first curve, the cube root of 6x plus 9 plus 8. So I'm going to press enter to let it know that yes, that's the one I want you to choose. Next, it tells me, hey, do you want the second one, the second curve, to be y equals 5? And I'm going to say yes, and I do that by pressing enter. Then it's asking me for a guess. I don't really care about the guessing, so I'm just going to press enter. And then what it does is it places the cursors where the two lines intersect. That's my answer. And down here, it gives me the point of intersection. It tells me that x is equals to -6, y is equals to 5. The solution to this equation is the x value. So my answer is, I'm going to write it down right here, because when they ask you to solve it, they're looking for an x value. So your x is equals to -6. And you have solved this equation using the calculator. All right. I do have a second problem for you. The second problem is a log-based type problem. So let's clear this out, and let's go ahead and type it into our y equals menu. So there's two ways. Let me go ahead and clear this. There's two ways to do this. I'm going to do it the first time with log of 5. Is because it's a log-based formula. So I'm going to go to math, and I'm going to go find the log-based function. There it is, option A. I'm going to press enter. So it's log 5, and then it has x plus 7 and the argument. And then I'm going to move over, and it says minus, and I'm going to use the log 5 again. So I'm going to go down to find it. And I'm going to put 5. And in this case, it has 2x minus 3 in the argument. And it says that log base 5 of x plus 7 minus log base 5 of 2x minus 3 is equals to 1. So in y2, I'm going to put 1. All right. Now, if you do not have that function of log base where you could do different bases, because remember that your calculator only does base 10. So if you have to do different bases, you either have to have that log-based function, or you will need to apply the change of base formula. So on Y3, I'm going to type in how you would type it using the change of base formula, okay? So you would say log of x plus 7, close the argument, divided by log of 5, close the argument, minus log of 2x minus 3, close the argument, divided by log of base 5, and close the argument. You got to make sure you close the argument. So now when we graph this function, oops, let me get rid of that 8 that I accidentally typed on there. Y1 and Y3 should be the same function, okay? So let's go ahead and graph it and see what happens. Notice how the graph turned blue first and then it went to black. So they turn out to be the same function. So that's, again, the two different ways to type it. So I'm going to put it back up there so you can see it. Log 5 of x plus 7 minus log 5 of 2x minus 3. If you have to use the change of base formula, you have to use a log of x plus 7 divided by log of 5 minus log of 2x minus 3 divided by log of 5. All right, so let's go back to the graph. We do notice that there's a clear point that the two graphs intersect, where that log function and one intersect. So I'm going to go and use the option second trace, pick option 5 for intersect. And again, it's looking for the first curve. Notice it's looking for my blue curve, but there's no asterisk anywhere. So I'm going to move using the left or the right arrow until that asterisk appears. There it is. Okay, so yes, I do want to pick that function. So press enter. Then yes, I want my second curve to be the y equals to 1. Press enter. And then press enter a third time. And then it tells me that the solution where these two graphs intersect is where x is equal to 2.44. And that is my solution for this particular function. Well, that's it for this time. We'll see you next time. Thank you.